Welcome back everyone to the Hello World Guide. This is another episode of the Raycasting series, and this is actually going to be the final episode of the Raycasting series for now. And in this series in this episode we are going to just go ahead and finalize some of the things which is going to be regarding having multiple enemies in the same map. So the thing is that since our enemy just has a generic pathfinding algorithm, they will find the same path if they happen to be at such a position that finds the same path. So they are going to collide, and then one of them is not going to be able to reach the player. So we need to basically add some form of avoidance. Now the proper way to do it would be to implement some other kind of algorithm and probably use a nav mesh instead of using a basic grid pathfinding algorithm, since our enemies are not constrained to grids, sizes or grid positions. But we can do something much simpler which is going to work in most cases and is going to be good enough for our needs in a game like this. So to start, what I'm going to do is, let me just open up pathfinder.h. So in here I have created a public set of nodes. Now this is just called occupied nodes, and the reason this is going to be useful is that this is going to represent all of the nodes that are currently occupied. And the way we'll use that is that we'll basically reconstruct this set every frame. Every enemy will basically put its position into the occupied nodes, and when we are doing the pathfinding, we'll just make sure that we avoid the nodes that are already occupied. So that's going to be actually pretty simple, not that complicated. So to try that, what I'm going to do is first of all we're going to open up pathfinder.cpp. In here you can see we were currently only checking the can stand. Now we'll also check if our occupied nodes has that next node. If it has the next node, then that means we should ignore the next node and move on to the other one. So we are going to just go ahead and have that here, and we'll need to basically reconstruct this every frame. As I said, we are going to have to clear it every frame. So in game.cpp, when we are updating, we just clear all of the nodes. Now this is going to work, and we are going to actually assign the nodes in thing.cpp. So when we update, the first thing we'll do is we'll insert the current node regardless of the current state, so that the monster can also avoid other idle monsters. We are going to just insert it into here. We'll just take our thing's position and insert that into the occupied nodes, and this would work for most cases. And the next thing that we need to do is well, we basically need to find out, well, there is a slight problem that we'll need to fix with the way we do our rendering. So earlier what we are doing is that we were basically sorting the whole thing list by distance so that we can draw them in the correct order. However, just basically changing the sorting of the thing list will actually change the order in which this occupied nodes get filled. And this might lead to some minor problems or some other things. So what we need to do is we need to make sure that that order of the things in the array or vector remains basically stable. So what we need to do is we actually don't want to go ahead and actually reorder the whole list. What we can do is, instead of reordering our vector of things, we can reorder the indices. So if I go down here to our render.cpp, in the render function you can see that we are reordering our things. But now what we're going to do is we are going to create a vector of indices. Then we are going to set it to the side and fill it with as many indices as we need using std iota. And then our get distance function basically take the index, and it will get the sprite from that index and use the calculations. And similarly, when we are sorting, we will actually sort our index. Now when we are drawing, we loop over the indices array and get the thing at that particular index. Now this means that our thing will actually not be modified. The thing's vector will remain in the order that it was, and we'll only use indices as basically an indirect pathway. It won't actually cause any noticeable impact on performance, because sorting an array of integers is much faster than sorting an array of things. So now if I run this, you can see I have got a new map here, and there are two monsters now, and they both try to come towards me and they find separate paths, and they both actually reach me correctly. And this does work, but it doesn't work in some cases. So as you can see, if I stand here, the monster gets stuck sliding when they're on the edge, because this place is actually too small for two monsters to move, because both of them are trying to avoid the wall. So it's not really possible. But there is some incorrect behavior as far as tight corridors are concerned, and this is the fix for this. The actual proper fix for this is, of course, to implement a better navigation solution. But something that will work for a fast-paced action game without causing too much trouble is to just make it so that the monster goes in a random direction if it can't reach the target for a few seconds, and that will make the monster look less stupid, and it will make the whole gameplay a little better, because the monster will find another path and will probably be able to find a path later. So anyways guys, this is going to be pretty much it for this video, and I'll see you in the next one, in which we're going to start our new series. So make sure to stay tuned for that, and make sure to subscribe so you don't miss that, and share this video with other people as well. And bye.